Hi, this is King of Review. Here we need to find the coefficient of a squared times b cubed in the expansion 2a minus 3b to the fifth. Now we could multiply this parentheses polynomial out 5 times, but that would take a long time and have a high likelihood of making a small error somewhere. Instead, there's a shortcut for expanding binomials, polynomials with 2 terms, like this one, called the binomial theorem, which itself has a nice shortcut called Pascal's triangle. Pascal's triangle is a triangle of numbers. It starts with a 1, followed by 2 1s, so already we're making a triangle. The third row starts with a 1 and ends in a 1, just like the previous row, but we're going to put a number in the middle, and we're going to get that by adding the 2 numbers that come above it. 1 plus 1 gives us 2. We'll do the next row in the same way. Start with a 1, add up 1 plus 2 is 3, 2 plus 1 is 3, and then we'll end with a 1. On the next row we'll start with a 1 again, 1 plus 3 is 4, 3 plus 3 is 6, 3 plus 1 is 4, and we end with a 1. We could continue like this as long as we wanted. 5, 10, 10, 5, and end with a 1. But that turns out to be all we'll need. What Pascal's triangle shows us is coefficients of what you get when you expand a binomial. The top row is what the coefficient if you raise it to the 0th power. The next row is if you raise it to the first power, then the second power, the third power, the fourth power, and the last row I have is the fifth power, which is the power we want to raise our binomial to. So what this tells us is that our expansion will have 6 terms with these 6 coefficients. 1, 5, 10, 10, 5, and 1. And these terms will all be added together. Now we need to fill in the rest of the terms, since those are just the coefficients. So we start with the first component of our binomial, 2a. The first term will have 2a raised to the 5th power, since that's the power we're raising our binomial to. The next term will go down by 1 exponent, 2a to the 4th, and we'll continue like that, 2a cubed, 2a squared, 2a to the 1st, and 2a to the 0th. The second term in the binomial, negative 3b, goes in reverse. We start with negative 3b to the 0, and we go up from there. Negative 3b to the 1st, negative 3b squared, negative 3b to the 3rd, negative 3b to the 4th, and we end with negative 3b to the 5th. This is the entire expansion to 2a minus 3b to the 5th. But now I want to focus on the term with a squared times b cubed so I can find its coefficient. And it looks like that's going to happen here in this term. Here we have a squared and b cubed. So I'm going to rewrite that term, 10 times 2a squared times negative 3b to the 3rd. If we distribute our exponents over their corresponding parentheses, we see that this will be 10 times 2 squared times a squared times negative 3 to the 3rd times b to the 3rd. And if we rearrange things a little, that's 10 times 2 squared is 4, negative 3 times negative 3 times negative 3 is negative 27, and then we'll put the a squared times b cubed at the end. So remember, we want the coefficient of this term, meaning we need to know what 10 times 4 times negative 27 is, and if we multiply those together, we get negative 1080. So that is the coefficient we want, and that's the answer to our question. Thanks for watching.